Welcome everyone to this morning's festival talk, and also welcome to our online audience. I have the pleasure today of introducing our speaker, one Hamish Donaldson. I think you will know Hamish as the founder and face of the festival, but you may also know that he is a man with many fingers, many pies, and many interests. Some, in fact, I've had the pleasure of working with Hamish on very closely over the years, and it seems there's always room for one more. So today, Hamish is going to be speaking to us about his latest passion, 3D printing. We have a printer here. For those online, we have a printer here in the room, which I'm not sure, are they going to see them, Will? No. So they'll be seeing them from that camera as well? Okay, so you will, at least afterwards, after the event, there'll be a recording which will be available, which will include some images of the printer, which is going ahead as I speak now. So Hamish, thank you very much, and we look forward to hearing all about your latest passion. Thank you.
This is a product of COVID. If you remember, we're all in lockdown in the year 2020, and we had to find things to do. And going for long walks is all right, but you know, you tire of that pretty quickly. Will was just saying to me, so why did you choose a 3D printer? And I think the answer is, I saw a chap who had a 3D printer and had a laser cutter. But the laser cutter required fans, extractor fans, and big problems in setting up. But the 3D printer looked as if it didn't. And then when I found the price, I get one for less than 200 quid. That seemed like a good investment, because we pensioners were getting more pay during lockdown and nothing to spend it on. So we've got it working there. So let's just have a look now at the printer. The main components. There is a roll of filament up at the top, which in my diagram is red, and in fact it's also red on the printer there. It feeds to a thruster. If you look, you can see on the screen there is a little red line that goes down, and it goes to a thing called a thruster. What the thruster does is it pushes the filament through a fraction at a time. It then goes through the white Bowden tube. I've no idea why it's called a Bowden tube, but that seems to be a flexible hollow tube it goes into. And it goes to a heated print head. The print head's at 200 degrees centigrade. And the way it works is like an ordinary computer printer, which is the head goes backwards and forwards. The difference is that the base also moves. So the printer goes backwards and forwards in the x-axis. The bed moves in the y-axis. But it also, the head is on a screw, and the screw goes up a fraction. So it prints on that layer, then goes up a fraction and prints the next layer. So it's actually printing layer by layer and building a solid object from that. Okay, so let me just show you now some examples. I found the program for this on the internet, and it seemed like a clever idea. One was in metric measurements, and one was in ounces and so on. And so I then, I'll now show you this working. If I can, now I've got to be able to move my, where have I got to? Well, I can't see where I put the, oh, there it is. Here we are. You can see it going across, and you can see the bed moving. So let me show you that again. I can identify this. Come on, cursor. Obviously, I had the sound on at the time. That all makes sense? Okay, and there you can see, I took some photographs as it was going along. It started by printing the base, then it started printing a bit higher, and then it went higher and higher. I have to tell you, I made 2 of these. I sent one to my brother-in-law in Denmark and one to my sister in Seattle. And they're absolutely useless. The problem is they don't fit in a drawer, and spoons do. But it was quite fun to make. But that's the finished objects measure. Okay. Now, when the Ender 3 arrives, it arrives in a flat pack box, and you can buy them assembled, which I recommend, by the way. But if you want the fun, then you can go and make it. Now, if I get this right, we're now going to go to this. You can see there's an address on the bottom of the screen. And if you click that, it takes you to a video, which is instruction. And what I used to do was I used to watch about half a minute at a time and then stop it and go off and do that half minute's work, which usually took an hour or 2. So I'll show you what that, and so one more thing is that I've actually got a handout which has got all of these details on it, which you can take away if you're interested. So you no need to take notes. Now I'm going to press Alt and Tab. Alt and Tab.
Box. The Ender 3 version 2 is well packaged with bespoke foam that keeps everything protected. The top foam lifts out with a little wiggle and you can see your 3D printed kit. Sitting on top is the assembly instructions, sitting on your print bed. Down the side you have some aluminium extrusions, these are for the frame. Then we have the XE axis kit. This holds the stepper motors for the X axis and the extruder, hence the XE. Then we have the display with control knob and part of the filament holder. The nozzle kit comes attached to the main base of your printer, so you have to be careful not to drop it as you wiggle the printer base out of the packaging. The other part of the filament holder is the last part from this foam layer, but there's more underneath. On the next layer we have a power cable, more aluminium extrusion, a Z-axis stepper motor, a bag of tools, a part called the Z-axis passive block, a bag with filament and other gubbins in, an X-axis tensioner, and finally a scraper. Lay everything out neatly in a clear area like.
Okay, now we're back to the slideshow. And it says here that I've got a handout with all these details on it. The price of the Ender 3 version 2 has gone up to £219. The first prints. I've got some samples here of the first prints. Let me hand them around. Yes, why not? We've got the that one is one of the first ones. Okay, and oh yes, sorry. Well, no, they can see it on the screen. They can see it on the screen. Would you like to? Let's see another one. Oh yes, that's the first one. I need to tell you how this works. When you get the program to do this, it's called an STL. I don't know why it's an STL, but then that's what the file is called. And I put it on its side on a program called a slicer. And what this program does is it saves the code which is used to actually drive the machine. And it's called G code. And it asks you various questions, which you see on the right-hand side here. You don't have to fiddle with the layer height because that's automatic, or the shell thickness. I don't even know what that means. But the important thing is when it comes to fill, it asks you what the fill density is. If you put it to 100, then you're going to get the whole thing is going to be absolutely solid. If you put it to 50, then there'll be a honeycomb inside. In fact, there is a sort of next to the screen, next to the fill, there's a little 3 dots there. And if you hover over that, it says that 20% is probably all you need. So the thing I'm making here, which you'll see later on, is only 20% density. So that is the hollow in the middle.
Hamish, shall I pass some others, please, around?
Yes, indeed, yes. And you can pass around also, not that one, but the teeth.
Teeth. Teeth are kind.
Oh, and also the toothpaste.
Not the tube one.
One of the first things I made, in fact, was this, the yellow thing on the screen, which actually allows me to save an awful lot of toothpaste in the tube. By now, it must have been getting on to Christmas or a grandson's birthday. I have a grandson called Hamish. And so you flat print the two things at the top. And when you push them out, it makes a wind-up car which careers over the kitchen floor. And that proved to be quite a success. His father was more interested in it than he was. Now this is interesting. When I first bought this machine, the red filament went straight down. You can't see it very well. But the recommendation was that you should actually push the filament out. I can show you this here. Do you see the white thing there? I had to make that. The white thing, oh, you can see it on the screen. White thing pushes the filament out and makes a better junction with the thruster. So I downloaded an image for that, but the wheel didn't look right. So the wheel, as you can see, is hollow, and I needed to get a solid wheel. So the problem was what to do. So I found a program called Tinkercad. CAD is short for computer aided design, and tinker means, well, tinker it. It's an online program. It allows you to build up shapes. And I'm now going to try and work on this with you to try and build a shape which we'll then try and print. Now, Alt. This is Tinkercad live. Now, what I've got to do is find out where my, there it is. And I can pick up a shape. Okay, I've got a shape here. Whoops, I made the shape change size. I'm going to put it there. Now I can make the shape any size I want. I'm going to click on it and make the width 120 millimeters. And then I'm going to go and make the, sorry, let's move that in. I'm then going to make the depth 50 millimeters. Okay. And then I'm going to make the height 5 millimeters. So let me just, you see, you can tilt the screen there. Is that all working up there?
Yes.
And so I can click the height and make that 5, which means it's going to make a platform 5 millimeters high, 120 across and 50 up. Now, what I thought I'd do is make a nameplate for screwing on a child's door. In this case, it's my wife. So what I'm going to do is I'm going across and I'm going to click text. And there's the text. And where it says text, I can type in the word Linda. And that can now go out of the way. And I can drag Linda across to here. Let's have a look at it. Perhaps a little bit higher. Okay. But now, if we're going to screw this to the wall, we're going to need a couple of holes in it. So what I can do is I can make holes by going across and grabbing a cylinder. And I'll grab this cylinder and I'm going to make it 5 millimeters across. So this will be a 5 millimeter screw hole. 5 across and 5 up. Okay. Now I'm going to try and move it into position, which I usually has quite a lot of problem doing. Okay, there we are. And I'll now duplicate it. Oh, so I've got to click it again. No, I've got to click it. Then I can go up to the top left here and I can do a duplicate. And then I can drag the duplicate over to the other side. I'm not going to fiddle with this at present much, but you get the idea. Now, what I'm now going to do is I'm going to make this into a single solid object. And to do that, I've got to select all of it. And then I make it into a solid object by clicking Make Solid. Right. Now, what I next have to do is to save it. And so that's done by going up to the Export button. And I export it as STL. And that will now save that image. And then what you now do as an STL, what I now do is, if you recollect, that's got to go to the slicer. The slicer will slice it, and then I can then put it on an SD card. Sure. The SD card is very small, and what you do is it fits in this little carrier thing. You plug it into your computer for a USB port. You then transfer the G code to this, and then you plug it into the printer, and then it prints it. You'd like to pass around the two windows.
And this is the object that's being printed. It just crackles.
I do worry that I've had this now 3 years, and it's not printing quite as accurately as it used to. So presumably, I ought to sort of reread the instructions and tighten everything up a bit. Now let me go back to my slide presentation. And so that's what we've been making in this nameplate. I downloaded it onto my slicer. I then pressed the 20% thing and saved it as G code to go on. Now, I made more gadgets. Unfortunately, I didn't know I was going to do this talk, so I threw them all away because they're cluttering up the garage. This is a marble ball device, which people like me enjoy making and playing with. And it's made up of all of these little components. And if I'll show you what they look like. You see on the left, there's a straight one and curved ones there. And the components you make it from, you print. You can see how those four fit into the two ends. You slot them into the end, glue them in with super glue, and that makes the carrier for the marble. And the other ones are stands and connectors. So if I just go back on slide, you can see that you can make quite a lot of these things and make quite a big sort of marble run, which indeed I did. Now, the next thing was a strand beast. I don't know if you've ever seen the video, but a Dutchman invented this walking robot. His was blown by wind. It's also life size. I mean, the legs are sort of my height. So it is a big operation. And if you type strand beast into Google, you can actually watch this thing walking along the beaches in Holland, which you'll recollect are all very flat. And I thought it'd be quite fun to make one. It turned out to be rather more tricky than I imagined. There are 8 legs, and they call them femurs and tibias and that sort of thing. So these are the components to make the legs. And as this cog turns on the right, so the leg maneuvers. But you've got to get connectors. And so, and they're 3mm bolts, but of course you can't really buy 3mm bolts. So what it meant was buying strips of 3mm rod and then cutting it up and then making sure that the nuts were fitted on it. So there are lots of bits here, and you can see that there is a thing at the top which holds it all together. There's also a platform down the bottom. I'm going to show you now the beast working. Where's the, I can't work out where the camera, oh, there it is. I switch on. Now, isn't that a lot of fun? I'm going to show it to you again. Where am I to? Can't see where the mouse has got to. Oh, there it is.
How many hours did that take?
How many what? Sorry?
How many hours?
Oh, quite a lot. But my fingers are not as dexterous as they were. And so Gary Mooreshead, Gary who operated the technology last week, Will's doing it this week, Gary helped me actually do the assembly of it. And his fingers are much better than mine at it. Now, I don't know if you can see, but these big wheels, the big cog wheels in the center, they're the ones that drive the smaller cogs to move the legs. So I had to get those revolving. And so there is a bar that goes between the two of them. And on that bar, I put another cog wheel. And below that, I found a little 3-volt electric motor. I had to guess what the speed was, but it said it was reduced. Speed had been reduced. So I took a chance that I'd get it right. But what I then had to do was I had to make a gear wheel that would connect to the gear wheel on the rod and then super glue them all on. And so there, you can see there's a white platform across the strand beast. And I put a switch at one end. The batteries are underneath. The motor is above, and the motor has a gear wheel on its drive, which connects to the gear wheel on the central rod. I imagine that sort of makes sense, doesn't it? Yeah. But you can imagine that actually getting everything the right size required a degree of experimentation. And I knew there must be a way of making gears. So I found a program which is called Gears. And what you do is you feed into that the size of gear you want, how many teeth you want, and what the attack is of the teeth. You know and so I had to guess all of that stuff. But interestingly, it did work. And I'm going to play it to you one more time because it's such fun. Also a problem to work out which way round the wheels had to go to make it go forwards. I suppose it didn't matter, but I went forwards or backwards. Yeah. Okay, so the platform holds the battery and the motor, the on-off switch, there's a tooth wheel. I've got a few gadgets here that I have accumulated to make these things. Hang on, I didn't want that. Oh, other fun prints. This is the false teeth thing, which you've seen there. And the only tricky thing with that is I had to put magnets in it, because otherwise the top false teeth fall out. And so I had to put magnets in. But the magnets, unfortunately, kept trying to stick to themselves. So I then had to put wood in each of the holes to stop the magnets jumping across. until they all got glued in. Quite fun. A Klein bottle. You've seen one of those before. They've got a single surface, although it looks as if it's 3D. And I've got the grandson has got one of these. I can't remember what they're called. It's not Scalextric, but it's one of these.
Brio.
Oh, Brio, that's right. And so I found on the internet a pattern, which I then had to go at making. Once again, when it got assembled, these wheels didn't work at all well. So I had to go back to my gear machine and create new wheels. So you're tinkering around all the time to make things work. But it's one of his favorite bits of the train set, because it's something you do. Oh, I haven't brought it. I'm not sure I brought them with me, but I had a tube of silicon. And of course, when you've used your silicon, it tends to dry out. So I knew there must be on the internet somewhere somebody who had actually made a cap. So I went there and I Googled a sealant cap and found one and made them. I think I've got some samples in here. And this is a gadget for soldering. So you make the bits and pieces, put them together, put an elastic band around them, and it holds things together that you want to solder. I meant to bring that, but I've left it in the soldering box. Oh, and this is another thing. I don't know if you have, but I've got an awful lot of plugs, charger plugs. And so keeping them tidy is a problem. So I made this platform to take plugs. And I made this, we'll pass this around as well, this holder. And I made a couple of these. So I've got 6 chargers now tidily on a shelf. So that was moderately useful. And Adrian, here is the, here are the, yes, but that's a protractor, but you can't actually read the measures. In summary, it's been a lot of fun. It can be useful, although I've got to say it's pretty marginal, and it doesn't break the bank. Okay, thanks very much.
So I think we can take questions. Will, are any online questions?
Actually, there was one question which I ought to answer already. You can, one of the things you might want to do is to scan an object. And so there are programs where you have an object sitting on a round table. You've got a scanner, and the round table turns round, and as it turns round, your scanner picks up the image. I've not tried that. It seems rather baffling to me. But of course, what you really want to do is be able to scan almost anything and have your scanner knowing where it is. But that's something I haven't done. But it is a challenge for the future. Right. No online questions?
Any questions?
Hamish,
Malcolm.
you have to download
No. The question is, do I have to download an app to actually get hold of the images? And the answer is no. You go onto a program called Thingiverse, and or you can just type into Google 50 things to do with my 3D printer. And it comes up with a program called Thingiverse. Actually, on that bit of paper there's another one as well.
This one?
Yeah.
Shall I hand this out?
Yes, please. Yeah. And Thingiverse is one thing.
Oh, yes.
And there's another one. So you just go there, and it has lots of images. You select the image, and it shows you files, so you can actually see what you're actually getting. And then you download it. It's usually downloaded as a zipped file, which you then open on your own computer, and then you can go from there. So the only program you need is the slicer. Anthony.
Hamish, could you give us some idea of cost?
Yes, the question is the cost of the filament. One of these big filaments costs about 18 quid.
And what difference does it make the quantity you use for your 25, 50, 75 density?
The question is, if you use different density, does it use much more or much less? And the answer is, I don't know. There's so much of the stuff there that it lasts an awfully long time.
How long does it take to print Linda's name?
Well, I started it at 11 o'clock. And so it's not doing very well. I somehow thought it would do this fast.
The other ones, those who disagree, how long do they take?
Well, the trouble is, you're near the running, so you're not there.
So I have another question: do you get a commission?
I've been asked if I get commission on sales. I wish. Sorry, Carmen?
The toothpaste squeezer looks good.
Yes, toothpaste squeezer, that actually came with the software for when you get your Ender 3, it comes with some software. And the software is the slicer and some samples. And also there's a little bit of filament, which doesn't actually make quite enough to make anything. But they have 3 images of 3 different faces that you can actually use for the toothpaste tubing. I've lost its name. So answer again.
Another boring one, Hamish. Have you experimented by changing colour from partly to
I haven't, but you can. You can pause the printing and change the filament, and they will run into each other. But of course, you've still got some in the system. So I've not actually done it, but you can pause printing to do that. So there's another question. Was it? Yes. You do see photographs of people with 3 spools of stuff on top, and I think that it's possible to buy printers that actually will feed 3 at a time.
Just getting on to that, I'm going to say we have a few texts that do 2 which is very similar to the Ender 3. So basically, you can, when you set it up on the SPL card, okay, on the SD card, you can say what percentage of which color you want, where you want to change.
That's
So that's a variation on the Ender 3.
GTEC, yes. Yes. You may ask, how did I choose the Ender 3? And the answer is, I can't remember. It looked fun and it looked cheap. Yes.
Is it working on Windows or?
I'm doing it on Windows. Yeah. But I imagine that there are Mac versions for everything.
But do you mean the software that's running on the printer itself? I guess that's.
No, that's independent.
That's independent. Yes.
Yes, it's just a slicer that works. So the question was, does it work on Mac? And I'm sure it does. But that's the slicer, not the. When you download the files from Thingiverse, I think there are Mac files there you can download as well as Microsoft.
Any further questions? Well, Hamish, I think that was absolutely fascinating. I'm sure everyone found it fascinating and very clear, I was. And I just want to point out what is absolutely typical. Hamish took delivery of this machine, not only constructed it, but saw the way in which he could improve it and used the printer itself to print this improvement, this white object here, which I think he should be able to sell back to the company who made the printer. So I think that is absolutely. So Hamish, thank you very much.